Alright, so here we have CSC110 underscore class 02 project, where I chose pattern number L, and it is obviously by me, Ryan Meyer. Now the project specs, or more like guidelines, if you will, albeit they are the specifications, is to print a 4x4 square, with each square repeating a pattern, and the pattern's colors alternate from square to square, along both the rows and the columns, so the end result will look like a chessboard, or checkers board, I suppose. You must use helper functions for this project. Make sure your functions include size and color parameters. This will allow you to scale the size and change the colors of the pattern that the turtle module generates. Your functions must have size and color parameters so that you can scale your output, make it smaller or larger, and change the colors. And then, so the pattern L in this case, is this wonderful, beautiful little pattern here. And it took a screenshot from the supply PowerPoint, and I believe this obviously is a picture from the book. And if you'll notice, you can see that the smallest recurring shape, or the smallest recurring pattern, is this 3x3 rectangle, or square, I suppose. Every single, the entire pattern is a repetition of this one square. Right here, it's the same thing, just rotated. Right here, it's the same thing, just rotated. And then here is the output of my pattern. And I resized it to 0.75 simply so that I could capture the image better. Otherwise it would be larger than the screen real estate and cause scroll bars to appear, and that was not desired. And it is a 4x4 grid. You can see that each pattern is repeating over and over again, and it's like a checkerboard. So the general idea for my project in and of itself was to change the turtle itself into the smallest repeatable shape, aka that 3x3 square, then use the stamp function built into the turtle to create the desired pattern or patterns. And a quick run through of what the code looks like live will be this. Boop, 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 boop. And it will proceed. And proceed, and proceed, and proceed. But now, getting back to it, the general idea of the turtle itself, repeat, so it is the smallest pattern. And for my helper functions, I had 4 helper functions that culminated ultimately into the one function that would be used to run the other 3 functions, as well as create the 4x4 grid, or in this case, the grid that is times size. And that if you wanted a 5x5 grid, you would simply enter in 5 rather, or a 10x10 grid would be 10 times. But the helpers create polys, which would be poly 1, poly 2, poly 3, poly 4, color 1 and color 2. The polys are, you know what, getting ahead of myself. Stamp shape is color 1 equals blue, color 2 equals red. Create square will be magval, and using magval as the operative for the resizing. If you were to enter in 0.75 for magval, it will be 1 times 0.75 the size. If you were to enter in 2, it would be 1 times 2 the size. If you were to enter in 0.01, it would be 1 times 0.01 the original size. And the original size would be of the polys that were originally entered. And then I have the swap color function, which is used to alternate colors 1 and colors 2. And it can be user entered color, as in the create pattern function, which will be color 1, color 2, repeating times magval, of which I've already explained. So, brief look at what create polys looks like, poly 1, color 2. It registers a new shape that replaces the turtle out of poly 1 through poly 4, aka every instance of add component here will create the shape. And this within the turtle module designates that it is going to be a compound shape, meaning that you can use components to create a single shape. This applies colors 1 and color 2 to specified polys, which poly 1 gets color 1, poly 2 gets color 2, poly 3 gets color 1, and poly 4 gets color 2. So they kind of alternate already. And having these 4 polys, they then, to have the turtle module registered as a shape, you use the command Windows, and it is WN because I had it be turtle screen equals WN. But register shape, my shape, comma S, and S being all of these and the turtle.shape. Stamp shape creates a shape for stamp and then stamps. So again, color 1 equals blue and color 2 equals red. I have the functions pass in this default value so that if you were to, for whatever reason, pass in no color variable or color value, it will fill in the blanks for you and put in blue and red. But it basically means it's an optional parameter within the function. And so then it creates a shape for stamp and stamps. And then I'm executing create polys. And then within this, I have it turn 90, and it rotates the turtle 4 times in a circle, aka 360 divided by 4, the simple shape of the pattern. And to create the simple shape, specified via create polys, which that shape is these 4 polys compounded into 1. So for I in range of 0 to 4, incrementing by 1, it will run test turtle, which is the name of my turtle, by shape, and it will create test.shape, and it uses the my shape as the variable, which in this case I determined that I'm registering the shape as my shape. So test.setH, which sets the heading, and I'm having it be setting the heading to turn, which is 90, and then I have turn increment by 90 degrees every run through of the for loop. So therefore, it will turn that little 3x3 90 degrees and stamp each time, thus creating a larger segment of the pattern. And that is executed within the create square function, and it creates a square that's composed of the desired pattern. The pattern is a turtle shape repeated 4 times, then repeating that 4 more times. So it's all compounded. I'm sure other patterns were different, but within my L pattern, it was somewhat recursive or fractal in that regard. I have shape size equal to 61, and I have 61 because it is the addition of all of these 30, 20, 10, 30, 20, 30, or rather the size of, it's basically the bounds of the shape itself. It will be 60 quote unquote points on the grid, which is executed within this setup, or this set world coordinates rather. It changes the grid increments that we are operating under for the turtle, for the animations and placements, and basically the entire numbers generation. But within this, so I have shape size equals 61 because that will be the effective size of the compounded my shape. And for n in range of 0 to 4 incremented by 1, and for I in range of 0 to 4 incremented by 1, I'll have it stamp the shape of color 1 and color 2, and then I'll move that turtle, the turtle itself, which is what is being stamped, forward by shape size, which is 61. Effectively, this shape size is what allows me to rescale and keep it, and be able to resize the entire thing with the final function of create pattern. But through that, I have move forward, which moving forward -4 times the shape size, because I'm using the shape size value as almost its own grid in movements, so that I can adjust by moving forward 4 shape sizes. Oh, I have to move backwards 4 shape sizes, and then I'll have it turn left, and then I'll have it go forward 1 shape size, which will increment it. It will move it up once, and then I'll have it turn right, and it begins the process all over again. I have it return test turtle.position, and I use that for debugging. The return is effectively entirely optional. It doesn't impact the way that I have the code written out, but if I were to have it print, say, create square with these values, it then prints the turtle's position, which is always valuable. Swap colors, and pretty rudimentary swap color function. You have color 1, you have color 2, and then I have a placeholder so that the computer can actually store the values of the color within memory, because because if I were to just say color 1 equals color 2 and color 2 equals color 1, then it just reassigns this color over and over and over and over and over again, and it will be the same color. Whereas if I have color holder, which is blank, equal to color 1, and then color 1 equal color 2, that effectively makes color 2 color 1, and I have color 2 equal to color holder, which used to be what color 1 was. And then I have it return color 1 and color 2, thus swapping them. Oh goodness. We can get rid of that, and get rid of that. There we go. So here's the big daddy on this one. Create pattern. Mag-val color 1, color 2, and times. It's the powerhouse of the cell. And no, it is not the mitochondria. Creates a pattern of create square, the function create square, as a times by times square with alternating colors. So again, almost fractal in nature. Squares changed in size via the mag-val value. In this case, could be 1. Simply 1 will just keep everything default values that you enter in. But square count equals 0, x equals 0. Test_shape_size mag-val. This is the effective part of what resizes everything, and resizes the pattern with a multiplier of mag-val. Thus the 0.75, 0.1, 2, 200, however large you want the turtle itself to become. Because that is what changes in size. Thus, when that turtle itself is stamped, it changes the size of the image and the pattern produced. So I have a while function, while true, test_goto, shape size times 4 times x, comma 0, and that prevents the turtle from creating squares on top of squares on top of squares, and it moves at approximate x distance along the x-axis. In this case, if I want 4 columns, it would be, that's how we get that value, because otherwise it would just be 1 column printed out 4 times upon itself. And this will allow it to be 1 column, and whatever that column's size is, it will be moved over that same increment, and then printed out again, and then moved over another increment, printed out again, and then moved over, printed out another increment. Thus, that is the go-to, which it absolutely moves it to that position, rather than forward or backward, which will move it from the current turtle position. I have x equal to x plus 1, thus as a counter, so that I can maintain the amount of distance moved every time I make a new column. And then for I in range 0, and incrementing by times, which is what allows it to be resized up to a 5x5 square, or a 6x6 square, if you would like. And it's used to facilitate the swapping of colors, and then it also creates the appropriate number of squares. So for I in this range, if I is not mod 2, if it is not equal to 0 of that, then it will create square, mag-val, color 1, color 2, and then it'll increment square count 1. And I'm using the square count to keep track of the total number of squares. That's basically telling it when to stop the entire loop, because as you can see here, oh no, if square count equals times, Jesus, oh my goodness, if times, and in this case, the default 4x4 will be 16 because it is a 4x4 square. Then it will break the while loop and exit out, thus it stops printing. But if I have it equal to, so if I is mod 2 and equal to 0, it effectively does the same thing, creates a square count plus 1. However, the reason why those are there are so that within this for loop it can execute the color swap, and therefore every square will be different that it makes. And if a square is being created, the colors will be swapped. And that effectively is how the whole pattern runs through. This one single while loop will go until that breakpoint. And so here we go for the execution. You have your various turtle setup rather. And this is what it would look like as it goes incrementally through the pattern. One of the most important parts of this entire concept is that you're creating the turtle. And to create the turtle from scratch, these are the effectively vector points, x and y points of the different shapes. Like you can see poly 1 is composed of probably just simply this little triangle right here. Poly 2 are these 2 blue pieces. Poly 3 is this red piece, and poly 4 is this 1 blue piece. And thus you compound those 4 and create 1. That becomes the shape of quote unquote my shape. And so each one of these is created on a XY grid. So 0, 0, and then this becomes 20, 0, and then this becomes 0, negative 20, and therefore we have one polygon. And then polygon 2 will be at 20 to 0, and we will have 30 to 0, and 20, negative 10, 10, negative 10, 10, negative 20, and it creates these two polygons, which in terms of the computer is referenced as one polygon. Poly 2, that's why it is so long. Same for poly 3. It is a larger, it's got a lot of different vector points or positional points, concave points. And create pattern, execute it with mag value 0.75, give it blue, red, and I want it to be a 4x4 square, so I put it in 4, and then exit on click, so that once everything is finished, it will actually stay open, and clicking will leave it empty. And one more quick run through. Let's give it this, and then we can watch it go, and I'll probably stop it shortly and let it just print out everything all at once. And there you go, you can see that it switched shapes, or it swapped the colors because there's a new section of 4x4 pattern. And as soon as it gets this line done, it will be another square, thus the colors will be switched and swapped. And it will do this 4 times. I also have the functions of the bounds and shape size within here, so that the setup, this window will be the approximate size of the entire content that the pattern will be. If it were to be magnified by 5, the window will become 5 times larger with the pattern itself. I view that very functionally, so that there's no more scroll bars. And there we go, we have it repeat down here, and it starts the tower once again, it makes a new column. So, we can go up here, and I'll turn on the tracer function for within the turtle, and that sets the 0 animations, and the computer will render everything prior to printing it out. So, quick, Control-Shift-B, blam, it's right up there. And now, functionality, if I were to change this to let's do 1.5. Now that is the mag val, and it is not centered correctly, but still functionally the same. And there we have it. The window size itself is that large of 4x4, but times by 1.5 or 1. And then if we were to do, let's say let's do 0.75 mag val, just to, let's do 0.5 mag val to maintain it smaller, but we'll make it a 6x6 grid. And there we have it. And again, the window is matched to its size. And we can even change these colors to, let's say, black, and let's say orange. And now we have a nice Halloween theme. And we can put it back down to 4 as per the request of the pattern. And let's make it 1. And there we have it. That is the natural state of it. And of course, the state would change slightly depending on these polygon tuples that were entered, the lists of the points that are being used to construct that shape that is becoming the turtle. And we could, going back up through here, this is just a quick run through, changing the light green, all the turtle implements, pen up, pen down, because if I were to have the pen be down, you would see lines going through and where the turtle is drawing from, which is not desirable because we are strictly looking for the stamp created by the turtle to create our pattern. And then my shape, stamp, set the heading, again shape size, somewhat not graceful of a implementation, but it works for all intents and purposes. If this value were to be 5, it would change it into a 5x4 grid. If they were to both be 6, it would become a 6x6 square that is then being repeated over and over and over again. And that about wraps it up for good old Project Turtle. But as you can see, it'll just keep going and going, and it does well. I like to think that the execution time is lower, but there we have it.